Okay, let's look at lesson 92, and in this lesson we're going to continue with a little geometry as we talk about classifying quadrilaterals. So a quadrilateral, quad, think of four, and lateral, you're going to think of side. So any object that has four sides is called a quadrilateral. So one, two, three, four. Four straight segments connected to make four corners are called vertices. Those are going to then form a quadrilateral. So any four sides, a four-sided polygon is another word for you. Polygon means many sides, is going to be called a quadrilateral. Now there are specific quadrilaterals, meaning that the sides or the angles, there's something special about them, and they have specific names. So we're just going to learn a little vocabulary and apply them to specific types of quadrilaterals. Here are a few of them. You'll notice that there are five specific quadrilaterals here, and you'll also notice that the first four, these right here, have the word parallelogram underneath them, because all of those are parallelograms. We'll talk about why in a second. You'll notice that the word rhombus is underneath two of them, because both of those are rhombuses, or maybe it's rhombi. And then the word rectangle falls under two as well, because they're both rectangles. And this one, object D, is even more specific. It's a parallelogram, a rhombus, a rectangle, but very more detailed, it is also a square. So we're going to talk about what makes something a parallelogram. All four of these are a parallelogram. What makes something specifically a rhombus, what makes something specifically a rectangle, and what makes something specifically a square. And then you'll notice the fifth one here is all by itself. It is not a parallelogram, and it is a trapezoid. So let's just identify these really quickly and talk about the features that make them what they are. A parallelogram. In order to be a parallelogram, you might see the word parallel in here. A parallelogram means that opposite sides of the quadrilateral are parallel. Parallel means that they never cross. If you were to extend those sides and continue to draw them right and left, they would never cross. Okay? So you'll notice here in object A, the sides that are across from each other are parallel. So the opposite sides here that I've marked with just one little mark, they're parallel, and the opposite sides that I put two little tick marks on there, those are parallel as well. So this is called a parallelogram. And you'll notice that A, B, C, and D are all parallelograms. Why? Because their opposite sides are all parallel. Okay? That's why all four of those are identified as a parallelogram. You'll notice that E here, it's called a trapezoid. It only has one set of sides that are parallel. The opposite sides of only one set are parallel. These here that are slanted are not parallel. So that's what makes it a trapezoid and not a parallelogram. Okay, what makes it a rhombus? Well, a rhombus is a parallelogram, but specifically when all four sides are equal in length. So all four of these sides are the same length. That's what makes it a rhombus. It's kind of like a square. You'll see here D is a square that's slanted or pushed to the side a little bit. It's kind of leaning over it. But all four sides have to be the same length. A rectangle is a parallelogram, but not all four sides are the same length, but all the angles are 90-degree angles. So they make a perfect little corner there in the rectangle. But not all the sides are the same length. A square is a parallelogram whose four sides are all the same length, and like a rectangle, it has all of the four angles equal to 90 degrees. Okay? So, if you were to continue to read that paragraph and this paragraph, it'll talk about the different features of those five quadrilaterals and tell you the difference between them, just as I've explained. So, which of these quadrilaterals is not a parallelogram? Well, that would be H, because to be a parallelogram, the opposite sides have to be parallel. So F, opposite sides parallel, G, opposite sides parallel, I, opposite parallel, and these are opposite or parallel, but H is not. Okay? A little practice here. This, now, you can give these objects more than one name if it qualifies. Meaning, A, you'll notice that A, if we were to best estimate the angle here, it looks like they're all 90 degrees, and all of the four sides look like they are equal in length, and opposite sides are parallel. So this would be a parallelogram. It would also be a rhombus, and it's a rectangle, and it's a square, just as was explained up here for D. B, the angles are not 90 degrees, so it can't be a square or rectangle. The sides are not all equal in length, so it can't be a rhombus, but the opposite sides are parallel, so this is a parallelogram. Okay? C, opposite sides are parallel. It's a parallelogram, so you put down parallelogram. And the angles look like they're 90 degrees, so it's going to be either rectangle or square. The sides are not all equal in length, so you would just say rectangle. And this one, D, only one set opposite sides are parallel. Only one set is parallel, and so it's only a trapezoid. It's not a parallelogram because the other set of opposite sides is not parallel. So this is a, this is a trapezoid. Okay? All right. Hopefully that is helpful, and that will lead you into the problem set here, which you can do on your own, and keep up the good work. Let me know if you have any questions.